The next true or false question is if y equals, oh, this didn't copy well, did it? If y equals x to the fourth plus 3x squared plus 2, then y is an even function. So we know that all the degrees here are even, but we do have a rule to prove whether something is an even function. It's an even function if I plugged in negative x, f of negative x equals f of x. And remember, f of x is y, right? It just says, okay, this is a function in terms of x. So we could substitute that in for y. So why don't we go ahead and plug in negative x and see if we get out the exact same function. So I'm going to take y equals negative x to the fourth plus 3 negative x squared plus 2. Well, negative x times itself 4 times is going to give me a positive x because 2 negatives make a positive, so 4 negatives make a positive. So I have x to the fourth plus 3, negative x times negative x gives me a positive x squared plus 2. Okay, so because these are the same, then this is a true statement. Y is an even function. So this is true. Next, the solution to the linear equation natural log of e to the x is 5 equals x, and x equals e to the fifth. Okay, so if I solve this equation, here's my solution. So friendly reminder that the natural log is log base e. Another tool we have in our toolbox is if I have the log of any number of itself, that's going to be 1, because that's like saying, okay, what power do I raise b to get b back out? Well, everything to the first power is just itself. So why don't I take a look at my equation here? The natural log of x equals 5. Remember, we have a rule where I can take my exponent in front. So I have x natural log of e is 5. I also know that the natural log of e, that the natural log is log base e. So let me rewrite it like this so I can see this a little more clearly. Well, any log to the base of itself is going to give us 1. So that leaves me with x times 1 equals 5, so I get x equals 5. So this is false. And the solution of this equation is, I could replace it with x equals 5. Next, true or false? The sequence 1 plus 2 plus 4 plus 8 plus ... diverges. Okay? So, when a series converges, the ratio, when a geometric series converges, this is a geometric series, right? We're multiplying by 2 each time, but we're finding the sum, so we're adding them up. Okay, but the ratio here is 2. This series diverges. Series only converge because they converge if r is less than, the absolute value of r is less than 1, right? Their ratio has to be a fraction. So this is a true statement. This series does diverge.